Hello, this is the key to the practice exam 2. First, we'll take a look at the question number 1. So question number 1 is about the probability distribution of a discrete random variable. Like here, x is a discrete random variable, right? Y is a discrete random variable because it has only like how many values? 5 actually, 0, 1, 2, 3, 4. And then the corresponding probability. And here, to be a valid probability distribution, it has to satisfy two conditions. Number one, each individual probability has to be between 0 and 1. And the sum of all these 5 probabilities together is going to be 1. Okay, obviously this is a that's why exactly how we get the probability for x equals 4, right? Because if this is empty, the whole thing is 1, then we have this one equals 0.6. Alright, how could we get the probability for x at least 2? See, at least 2 here, x greater and equal to 2. So at least 2, we could be, you can see here 2, 3, and 4, right? That's how we add those 3 probability together, 0.7. Or we could do at least 2, 2, 3, 4, and then we just do not have 0 and 1. That's why we use 1 minus the probability 0, probability 1. So both ways would end up with the same solution, 0.7. Okay, how to find the mean and the variance of x? Remember, the formula for mean is the little x times the probability for capital X to be little x, and then add all of them together. How? Yeah, because this summation, is a little confusing at the very beginning. That's why we could use this table to understand what's really going on for this summation. So first we do this cross product. So the corresponding x values, and then the probability for capital X to be that little x value, and then multiply together. 0 multiply 0.2 equals 0, 1 times 0.1 equals 0.1, 2 times 0.2 equals 0.4, and 3 times 0.1 equals 0.3, 4 times 0.4 equals 1.6. That's what we mean by x value times the probability of its corresponding probability. And then we add all of them together. That's what we mean by sum, which is 2.4. So the mean of x is 2.4. How about the variance? Variance is much more complicated. Okay, first we have to figure out the squared deviation, and then use the probability as the weights for the so-called weighted average, right? So how could we do that? And we already know mu is 2.4. So the squared deviation xi minus mu is, for this case, 0 minus 2.4, and then square it. That's how you get this guy. And then 1 minus 2.4, you square it, you get this guy. 2, 3, and 4 do the same thing. That's how we get this column. And weighted by the probability, basically times the probability. So we use this guy times the probability 2.4, excuse me, right? That's how we get this one. Yes, this should be 11.52. Okay, this is a typo. And then 1.96 times 0.1. That's how we get this number. And 0.2 times 0.16. And then we add them together, ends up with 2.44. That's the variance. Okay. And then what is the probability for x less than 0 and y? Because remember, capital X is a discrete random variable which only has 5 values 0, 1, 2, 3, 4. So it's impossible to get a value less than 0. Okay, that's impossible. Here should be capital X. Alright, question number 2. Question number 2 is about a binomial distribution. For this binomial distribution, we need to figure out what is the n, is the number of the Bernoulli trials. What is little p? Little p is the probability of success. So in this case, suppose 4 adults are randomly selected, right? Just think about this one. Each individual adult is selected. That's a Bernoulli trial. That adult could have a college degree or not. If yes, that's a success. If no, that's a failure. This 20% is exactly the chance for that adult to have a college degree, right? So we have the n equals 4, p equals 0.2, 20%. And then what is the probability that all the 4 adults have a college degree? So this is the probability for y equals 4. So here y denotes the number of adults out of 4 who have the college degree. So we use the formula. That's how we get this probability. Okay. And then what is the probability at most 2 of the 4 adults have a college degree? At most 2 basically could be 0, 1, and 2. Okay, we just figure out the 3 probabilities and then add them together. Or we could just go the other way around, right? This is the complement rule. So for the n equals 4, right? So here y could be 0, 1, 2, 3, 4. So here 0, 1, 2, only 3 and 4 are excluded. That's why we use 1 minus the probability of y equals 3, the probability of y equals 4. Okay. Both would end up with the same solution. Okay. For part 4, we're talking about the variance, expected value, and standard deviation. So we just use the formula n times p, right? A is 4, p is 0.2. That's how we get 0.8. And then plug in, get 64, and then take the square root, get 0.8. Alright, now if we say we have 100 instead of 4 adults randomly selected, then what should we do? We could just do it by hand, but since this n is so big, right, it's 100. Take a look at this one. What is the probability less than 10 adults who would have a college degree? So here, y is less than 10, okay, the probability. So that is equivalent to probability of y less than or equal to 9. If we follow the way we did in part 2, then we have to do how many times of that kind of calculation? From 0 to 1 to up to 9, we have to do 10 times. That's too tedious, right? That's exactly we have to turn to the help of the R. So in our case, we are going to use this command here, right? That's exactly the probability for y less than or equal to 9. So this p by norm, right? That's exactly for the cumulative case, okay? But if we do the d case, that's only the probability for y equals 9, just 1 point. And here with the p, that means the probability up to 9, right? Less than or equal to 9. Alright, what if we want to know the probability at least 10? So we have to figure out the probability of y greater than or equal to, do not forget this equal sign because this is at least, right? Now say if we do it by hand, we have to keep going 10, 11 up to 100. That's impossible, right? So the common trick here, we use the complement rule, use 1 minus the probability of y less than 10. we already know this probability from part 5. That's why we plug it in. That's how we get the probability, okay? Question number 3 is about the normal distribution. This is not a standard normal because its mean is 72, standard deviation is 8. So if y we denote the scores of a management aptitude exam, so in this case, a randomly selected manager will score above 70. So we want to know the probability of y greater than 70. Then first we transform y into z, right? Minus the mean divided by standard deviation. So we do the same thing for 870. That's how we get a negative 0.25. And then we get the probability. And then how about the sandwich probability? So we do the same thing, right? Both ends. And then we could easily get the probability from either by the table or by R. What is the lowest score that will place a manager in the top 2.5% of the distribution? So this is a typical question for the inverse probability problem. So when you figure out what is this little z, of course this capital Z has a standard normal distribution, right? And if we go to the z table or use R, we could find the little z as 1.96. And then how could we get this little z? That's exactly little y minus 72 divided by 8. With this simple equation, we end up y equals this number. Question number 4, still about normal distribution, but here we gotta be careful. This is about sample mean. So we have two distributions involved. First is the so-called population. So this is like the parent distribution, right? This is the normal with mean 50 and standard deviation 12. And then what is the distribution of this X bar? This is so-called sampling distribution, right? Sampling distribution would have the same mean, which is 50. But for the variance, it's gonna be divided by what? The sample size. In our case, n equals 36. That's how this X bar has a normal distribution with mean at 50 and the variance as this number, okay? The same thing we would figure out what is the probability for X bar between 47 and 53. So we will do the same thing as we did in part 3 in question number 3. Alright, now let's talk about question number 5. Number 5 is about Poisson distribution. And for the Poisson distribution, the nice property is like this one. 18 visits over a 30-day month. And then we split the 30-day month into 6 5-day periods. Then each period will get this average visits as 3. How do we get 3? Because think about, 5 out of 30 is 1 out of 6, right? And then use 18 times 1 over 6. That's how we get 3. So how to interpret this one? So this 18 visits can be evenly split over these 6 5-day periods. Each 5-day period gets 3. And the amazing part is, for this 5-day period, with the 3 as the average, we can still follow the Poisson distribution. That's how we could get the probability for x equals 5, right? Follow the formula, we can get the probability. And if we want to know the probability a customer visits the chain at least 3 times, so probability for x greater than or equal to 3. Yes, this is the common trick, right? We explained it before already. So because the Poisson distribution is for infinity, so in our case, x greater than or equal to 3 basically means 3, 4, 5 up to infinity. So there is no way we can go this way. That's why we have to go to the complement rule way, which says use 1 minus 0, 1, 2. What's left is 3, 4, 5 up to infinity. So we only need to figure out the probability for 0, x equals 0, 1, and 2. Add all together and then use 1 minus the sum. That's how we get the probability. Okay. And for question number 6 is about continuous uniform distribution. So for this one, continuous uniform distribution with a lower limit or lower end at 10, upper limit upper end at 30. Then the height of the density function. And we know that the density function for continuous uniform distribution is just a flat line. Okay, the height exactly 1 over b minus a. Okay, a equals 10, b equals 30. So the height is going to be 1 over 20, 0.05. Calculate the mean mu and the standard deviation sigma for the distribution. Mu is actually average of these two limits, two ends, right? A plus b divided by 2. And the variance is inside the square root. Okay? Is the length of the interval squared divided by 12, and then take a square root. That's how we get the standard deviation. What is the probability for x is greater than 22? So here we got to know that, okay, this x is greater than 22 but cannot go beyond 30. Okay, that's why we use 30 minus 22 and then divided by the height. Or you can say divided by b minus a times height, excuse me. Okay. So this is the base times the height. And then what is the probability x is between 15 and 23? So 15 and 23 because both are within these two ends. That's why we use 13 minus 15 and then times height. Or equivalent to say divided by b minus a, which is 0.42. What is the probability that x is 29? So here we could use two ways. One, we say, okay, 29, you got a greater than 29, less than 29, right? That's what, 29 minus 29, 0. Or you can say x is a continuous random variable. What is the probability for a continuous random variable equals just a single value? Is always going to be 0. Okay, this is a very interesting property for continuous random variable. That's why just last comment. Okay, so for our postponed case here, x greater than or equal to 3, this equal sign matters, right? Because you know we have the 0, 1, 2. If there is no 3, then we have to put the 3 here also. Okay, so for the discrete random variable, with the equal sign or without the equal sign doesn't matter. But for continuous random variable, like here is the continuous uniform, right? Like here, you put the equal sign on both ends, or you do not have the equal sign on both ends. Does not really matter. Okay, right? So that's because whenever for one single value, the probability for x equals a single value is always going to be 0. The same thing for the normal case. Okay, here, equal sign, right? But without equal sign, it would be the same as this probability. Okay. All right. I hope this little video will help a little bit. And if you have any questions, let me know. Thank you.